Second method which cryptographers talk about is differential cryptanalysis and then the linear cryptanalysis. So what is differential? Differential says that if I give you a plain text, so you select the key, but I give you the plain text and you give me back the ciphertext. Then after doing enough number of times that thing, I can guess the key. The way it works, the name differential means that what I do is I take delta x and delta y pairs, where delta x is the change in input bits and delta y is the change in the output bits. So I give you 64-bit, you give me 64-bit, then I give you some other 64-bit with some difference, maybe 1 bit changed, and then I see what bits change in the output. Then I give you some 64-bit and then 1 bit change, and so on and so forth. So if I do delta x, delta y pairs, and then I calculate the distribution of these pairs. All right? Some pairs have very high likelihood and some pairs have less likelihood. Just like frequency analysis. So I find out if I find any pair which is in my list of high likelihood, then I know some pieces of the keys bits. I can say, well, I think key number 40 and key number 23 and key number 56 should be 1. So you don't have to try those variations. Other than that, you should try all other variations. All right. So based upon the frequency or based upon the statistical distribution of delta x, delta y, they can reduce the search space to lower number. They can reduce it all the way to 2 raised to 47. So how many we got? We got 8 bits less. It turns out that doesn't really help, because to get those 2 raised to 47 plain text, you really need to do some work, and somebody did the calculation that to do that work, if you do that work plus 2 raised to 47 this one text, you really have end up doing 2 raised to 55.1, which is more than 2 raised to 55. So this is really very resistant to this kind of analysis. All right. If you want to know about differential cryptanalysis, I would recommend that you read the Wikipedia. That is much more clearer than the book. All right. And oftentimes when and this is in general nowadays true, that if I don't understand something, I go to Wikipedia. I know Wikipedia is not always correct, but it is somewhat always written for general public, so it is clearer. And in this case, for example, I found differential analysis was much more easier to understand from Wikipedia than from the book. Differential cryptanalysis is a complex topic. You probably have to read the book part 2 or 3 times yourself. I read it 2 or 3 times. But the analysis is very simple, basically. What you do is you make some number of changes in the input bits and then find out what output bits changed and then keep track of that, get a distribution of those changes, and by analyzing which are most frequent changes, you can figure out which bits in the key are fixed by doing this difference, delta x and delta y. That is one analysis. The second analysis is linear cryptanalysis. In the linear, you try to fit a linear equation between any bits in the input and the output and the keys. And obviously, this will not fit perfectly. If it was so easy, then you don't need to do anything. You can just, you would do the analysis. So all these block ciphers are first of all designed so that no such linear equation holds. But by analyzing how much they hold 50% of the time, 75% of the time, 100% of the time, or 10% of the time. You can guess some bits. Again, you can reduce your exhaustive search by figuring out how often whatever you think holds is holds. So So what you do is you calculate bias. Bias is what is the probability that this relationship, and you can write down any other relationship, holds, and then subtract it from half. So let's say it is 0. That particular combination never happens. Then 0 minus 0.5, you take the absolute value, the bias is, how much is bias? 0.5, no, 0.5, right? So you take the combination that have the highest bias. So even if some shift combination does not happen, that's a good information. So you can then fix certain bits that this combination doesn't happen, and therefore these bits in the key are fixed, and we can reduce the work. If some combination happens all the time, which is kind of unlikely, that probability is 1, it is equally good information. If something happens 50% of the time, then the bias is 0. It's no good, because that's what it is designed for. So then you really can't guess much. So more off from 0.5 you are on either side, the better it is for you to be able to guess the key. So the bias is calculated as the probability minus 0.5 absolute value, and then you find the linear approximation which has the highest bias, and then you can reduce your search effort. Alright, so people have shown that this key can be found in 2 raised to 43 plain text. So this is 4 bits better than 2 raised to 47 that we were talking about before. 2 raised to 47 became actually 2 raised to 55, so I don't know what this 2 raised to 43 becomes. So this is basically, you will need some effort to find this kind of equations and bias and all that, and then you start your search and so on and so forth. So this is another possible way to attack it, but obviously we are not using this anymore. We are using triple des, which is probably 2 to 3 times stronger than this. Alright, so we talked about 3 ways of attacking, which really means 3 ways of reducing the effort to attack. The attacks are not straightforward. It is not that you get the answer. Really you have to do brute force search, because these are very non-linear things. That's why, actually this is a linear relationship. See, that's another interesting thing. This is a linear cryptanalysis. So there is a linear relationship between the input, output, and the keys. And any linear relationship, if it exists, is a strong weakness. And so all those S boxes were designed exactly to avoid that you cannot write any equation between the input and the output keys. In fact, that was one of the major changes that was done in the IBM's version by NSA to avoid that. They had some boxes where people could figure it out. And so they changed the boxes so that now there is no linear relationship left. All right, so that is all about DES, and that is all about most of the block ciphers. And so here are the 5 or 6 principles. First of all, the S boxes should be non-linear so that they can be resistant to linear cryptanalysis, and linear approximation between the input and output bit of the S boxes should have minimal bias, so that the probability should be half. You give any relationship, so you take any box here, and let's say this box, and you say, well, I think the output can be the first bit is as it is, the second bit is a complement, the third bit is complement, and the fourth bit is complement. You take that relationship, right? You do it in this box, you will find out that it's true for 50% of the cases. Right? So there is no bias. Or any other relationship you could take. You could take exclusive or among these and so on and so forth. So that is first design they do, is that the S boxes have to be very non-linear, that you cannot fit any linear function. And they have to be resistant to differential analysis, so delta x and delta y. If you change some bits in the input and some bit in the output, you keep track of that and do the distribution, you will find that there is no peaks and valleys there. Any output should change with probability half when any input bit is changed, and this is called strict avalanche criteria. Basically what that means is diffusion. Half of the, any bit changing has a probability of half when we change one bit. Output bits j and k should change independently when any input bit I is inverted for any value of I, j and k. So this is another criteria they have added. So whenever somebody comes up with a new algorithm, people check it out against all of these. So this is called bit independence criterion. Finally, permutation should be such that the adjacent bits should affect different S boxes in the next round. So that means increased diffusion. You do the permutation so that the bits which are next to each other, they become far away. The bits which are far away will become close to each other, and so the effect widens. And more rounds are better, but also more computation. So 16 rounds, if you are not happy, just 32 rounds would be better. 48 would be even better, and so on and so forth, except that it is just a lot more work. So these are all 6 principles that we have learned in this lecture. All right, that brings us to the summary of today's lecture and 5 key points. First of all, what Shannon told us, that we need to increase the confusion and diffusion. And remember, diffusion, if you forget what is diffusion, remember that is spray. Diffusion means, expand. One bit changes all the bits there, right? And confusion is related to complexity, C and C, right? So if there is a complex relationship, that is confusion. Then the 5-step design. 5-step design's strength is that it is simple to implement and still invertible. So you don't need to design a decryption algorithm. It's already decryptable. So those are the 2 big guys, Shannon and 5-step. And so we got DES out of that. DES has 16 rounds, that it takes 64-bit blocks, that it takes 56-bit keys, things like that. Okay, that its S boxes take 6 bits and put out 4 bits. Those are the overall things that anybody should be able to remember, and there are 8 S boxes, things like that you should remember, but not the actual tables. Those you don't have to worry about. Alright, so it uses 16 rounds using 56-bit key, from which 48-bit subkeys are generated, and each round uses 6x4 S boxes followed by permutation. Then what is differential cryptanalysis? You should know that, at least, that it is basically analyzes the frequency of the delta in the plain text and the delta in the cipher text. And linear cryptanalysis analyzes the frequency of linear relationships similarly. And so based upon those are the 2 analyses. And then the block ciphers should be non-linear, complex, and maximize the diffusion. Another name for diffusion was avalanche.